Yeah, it's a very long notebook. I'll just give it to you so you can study on your own. So many stuff in here. There's also an image classification one here, but yeah, I have the answers here. I'm gonna delete it first before I give it to you. Okay, you can see it, right? Great. So let's start. We typically do data visualization with the data set that we have, so you get a proper understanding of what you're dealing with. But before that, you have to import the libraries. It's a given that you have to import NumPy, Pandas, and Matplotlib. Standard stuff. Other parts here you can ignore, but it's just for aesthetic purposes. So we'll be using the Iris dataset, a very popular dataset in machine learning. You can ignore the other parts here for now. You can study them on your own, but the point is I'm just loading the dataset and I'm checking the shapes, some sanity check. I'm gonna leave it to you to understand how this is being done. But again, as I said earlier, you have to split your data into train and test. No hyperparameter tuning for now. So just train and test. Okay. And this is how you do it. Oh yeah, we'll be using sklearn. Sklearn is like the standard library in machine learning. So yep, I'm just loading the dataset. Okay. See datasets upload iris and then train test split. This is a very common function that you'll be seeing in machine learning, train test split. So what is happening here? We split the data into two. You have your train and test, and the size of test is 0.2. Of course, the size of train is going to be 80% if the test is 20%. Random state, set it to any number, but be consistent with it. So this ensures that your results are reproducible. Just set it to any number and stick with that number. Okay. Following? Yes, I believe. That is clear, right? Clear so far? I'm not sure if it is clear. Thumbs up, please. Yeah, thanks. Okay, let's proceed. So yeah, some sanity check. The original size of our data set is 150 rows and 4 columns. So if you split them into like 80-20, that's going to be 120-30. Just some sanity check. Then we visualize the data. Just some code for doing that. I will leave it to you to understand how this code works, but just want to have an understanding on what our data set looks like. And visually, you can already see that there's a pattern. If your data is here, then your class 0. Class 0 is what again? It's setosa. 1 is versicolor, 2 is virginica. If it's here, then it's setosa. If it's here, then versicolor, virginica. If it's here, then virginica. But again, we're just looking at 2 features, 2 dimensions. We have 4 dimensions, right? Sepal length, sepal width, petal length, petal width. Just visualizing it using the first 2 features. Because why not? We can already see that the machine learning model might be able to identify or classify the classes of your new data points, because there's already a pattern here. So we have done the splitting, right? Train test. So the black data points are the test set. So what we're doing here is just showing you that these are the unlabeled ones. And if we classify them later after we have trained the model, this will look the same as this. We'll be assigning labels to the black data points. So it's something that won't be seen by the model. That's the general idea. So yeah, that is the exercise. We implement the distance measurement and the other parts here. So what is it? I'm just going to delete the answers later. So implement distance measurement, this extra stuff needed. Get nearest neighbors and classify. There's a template code that I will provide, so don't worry about that. Yeah, we're going to implement the min cosine distance, the general one. Oof, 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 oof. Do we have the answers here? No. Yeah, it's not here. So you replace this with the answer, but I have it here. Oh, this is my implementation. We're gonna use NumPy for this. Oof. And then yeah, and then for the other sections here, some extra reading if you want to learn more. And there's a lot that I've included. Oop. Yeah, that's it. I'll share the notebook later. Questions? So now we can apply what you have learned in the previous sessions that we had. So I've shared you my resources, how to do like NumPy and Python. So yep, you're gonna use them here. So basically, you just implement this. You turn this equation into code. Pretty straightforward if you know how to use NumPy.